bidirectional Bert basically. Let's see. So before starting with the Bert, so first of all, before uh, we are just going to discuss basics, like before learning about Bert model. So first of all, this is example of sequence to sequence model, or suppose you have RNN, LSTMs, etc. So suppose you are having set of sequences and you want to train your model. You have set of sentences and you want to train your model on those sequences. Okay, so what was the issue with that was, I'll open up Notepad. Okay, so what happens in a simple LSTM or RNN was, I have a sentence like cat eats rat, or suppose I have a very lengthy sequence. So in a sequence model, any sequence model, like RNN, LSTM or something, and if I'm having multiple layers, so what happens is this is unfolded over time. Okay, so there's no concept of parallel processing. So once these have given output, it will be at t is equals to 1, this will work, at t equal to 2, this will work, at t equal to 3, this will work. So there's no concept of parallel processing in this. So to avoid that, first thing was if all the text is processed sequentially. So there was no parallel processing in this kind of scenarios. Secondly, if we have a long sentence, suppose very large sentences are there in the data, at that time what will happen is it will suffer from problems like vanishing and exploding gradient problems. Vanishing, exploding, and most of the time gradients are lost whenever they are traveling from over the large sequences from left to right. So gradients are lost most of the time. So what happens is, to avoid this, even we are using LSTM and GRU avoids these problem, but even in case of very large sentences, LSTM and GRU are also not able to avoid loss of gradients. They are also not a foolproof solution to this. So to avoid these two problems, a new concept came, which was transformers. Now, before discussing about transformers, this is a simple encoder-decoder architecture where you are converting a sentence from English language to any other language. Okay, so if you are converting something, so basically you are in a simple encoder-decoder model, you will generate an intermediate representation, and that representation will represent best features from your sentence, whatever you have generated. It will understand your sentence and it will generate a new translate it into new language. Okay, now there was problem in this. Problem was information bottleneck. Suppose again you have a very large sentence, very large sequence. So what happens is, in encoder also, if you have a look at it, encoder will be having layer 1, layer 2, multiple layers, and you are feeding your sentence over here. So it will generate intermediate representation. So suppose if it was a very long sequence or something like that, so last layer would be burdened with lot of information. Okay, and all the representations are stored in the intermediate part where you are storing the representations over here. So similar goes with the, so problem is information bottleneck with the encoder decoder. So in encoder decoder we are facing some problem, in processing sequential models also we are facing some problems. So to avoid this, various new algorithms came. Now let's have a look at, so this was the shortcoming, like variable length sequences plus fixed length memory, because we are having, suppose we are having a very large sequence and this was having a particular few set of neurons. So neurons were not, so this model was not designed for very large sequences. In that case, so it will not work quite well. Okay, so this was the problem, and secondly, information bottleneck was the problem. Now, to avoid this, attention networks came. So in attention network, what happens is, so we are getting into details of attention networks in next unit, but just to give a brief idea about this. So in attention network, what happens is, only particular word in a sentence that is important is given more attention. So attention is all you need. So this is, suppose you are talking about a person named XYZ, and he wants to play with some person named ABC. So if I'm talking about this XYZ and whole sentence is about XYZ, so this XYZ should be given more attention, because we are talking about this. So context is about this person. So in attention network, some particular words are given more attention. Okay. So now, another concept was transfer learning. So we are just revising the basics before moving on to BERT. So BERT we'll see what it is, what it does. And before starting with the BERT, we have seen the problem with RNN. We have seen issues with the encoder decoder, and we have seen we have seen attention network. So in attention network, we are just trying to give attention to specific words that are more important in a sentence. Now, one more thing is there is transformers. So we'll also have a look at it later on. Now let's see transfer learning. So in transfer learning, what happens is, we have some data set, we train our model, and we use the same model, same weights. We don't train our model from the scratch whenever we want to uh, uh, do something, or maybe perform apply predictions for our data set. So for our data set, we'll just use a pre-trained model, whatever we have already trained, and we will give that as input to the pre-trained model, and we will add certain layers in the pre-trained model, delete few of them, and we will use the pre-trained weights. We'll start training from those pre-trained weights, instead of training from the scratch, instead of training the whole model from the scratch. So this concept is also used in BERT. So let's see. Now, now let's move on to BERT. So BERT is nothing. It's just bi-directional. First is bi-directional. So if I'm talking about bi-directional context, so this is, suppose this is my intermediate word and I'm talking about it. So left context is also important and right context is also important. So most of the models, for example, a sequential model, they go from left to right. So bi-LSTM solve this problem by training from left to right and right to left. So bi-directional model. So BERT is also a bi-directional model. We'll see how this works, and we'll see how BERT is trained for the data sets. Now this is the outline of the models up till date. There are also many other algorithms that came. So first one was, let's see. So this is nothing. This is just advantages of transfer learning. It just reduces training time because you are not training models from scratch. You are just improving predictions, and you don't require huge data sets for training on a transfer learning. So these are all the advantages you get while you use transfer learning. Now let's see. So first approach was continuous bag of words. So in this, we have seen, like, we have a, suppose this was the word I want to talk about, and left context and right context, these two contexts are taken while training for this word. So but disadvantage of this was, like, it is having fixed window, so we don't know how much context from left and how much context from the right should be taken for training on this particular word. Suppose side of the street, so I want to take this much context for this right word. Okay, so this was the issue with this continuous bag of words. So to avoid this, Elmo came. In Elmo, they used RNN and specifically bidirectional RNN. So it was, so suppose I want to find out this, predict this word. So I'll take the left context and I will also take the right context. So it will train from left to right as well as right to left. So it is a bidirectional model. Now again, the disadvantage was vanishing gradient, and suppose the sentence was very long. So that thing was there. So then GPT came. In GPT, it utilizes the concept of transformer. So uh, GPT, sorry, in GPT, it is unidirectional and it uses decoder. And decoder, so in encoder, you are encoding the sequence into representation. Sorry.
I have a question.
Yes.
Ma'am, when did the models transition like from basic bidirectional LSTM to like more modern transformer and attention-based models? Like what, which, because I think you mentioned in the paper attention is all you need.
Mhm.
So like when did models transition from using bidirectional LSTMs to like modern architectures?
So it is a whole, actually what happens is, yes, so first of all, the sequence model came, and then actually what was happening is this RNN was previous to, it was earlier concept, very old concept, but Elmo came later on for the specifically for text. Now, first of all, continuous bag of words were used, and then Elmo came, and then Elmo utilizes the concept of that RNN itself, and LSTM was also very old concept, but GRU came later on after LSTM. So bidirectional LSTM was after this. So actually there is no, sequential timeline for this because so many things are interrelated, but this bidirectional one is taken from by this in Elmo, bidirectional is taken from bidirectional LSTM itself. And then so it is not very old concept, these concepts are not very old concept. Bert is, I think, very later concept to in past 5 or 6 years. Bert came, and before that GPT came, and GPT is I think before 7 to 8 years, I'm not sure. So it's not very old concept, these concepts are really, and before GPT, transformers and attention came. So it is so attention came after this sequence models. So this is a timeline. First of all, sequence models, then attention and transformers, and then GPT, and then Bert.
Okay, ma'am. Okay, ma'am.
So attention was basically attention was idea behind attention was because RNN was not able to give attention to few words. So attention is all you need is the research paper which published this idea, or like we need to give attention to certain words which are more important. So to remedy the situation with RNN, attention came, and then this transformer. So transformer is also very latest concept, is not very old, but these days it's getting, so many variants are coming for this transformers also. Okay, so RNN. Then it utilizes bidirectional thing. Transformer. So this GPT was, it utilized decoder only, and it was unidirectional. Okay, so while we'll study transformer, we'll get into details how this works. Okay, and then after this GPT, so we have seen CBOW. Then came Elmo, which utilized bidirectional RNNs, and then came transformers or attention, whatever, and then GPT, and then BERT. So, um, so in BERT, it utilizes the encoder. So we will see. So advantage of BERT was it is bidirectional. It uses transfer learning, and it is encoder architecture, and it is very popular. So these days in Google search, if you are Google is, I think, using this one, and suppose you are searching for a sentence. So suppose you are searching for a movie dialogue. Okay, so give example of any movie dialogue. So I think so so for example, for a particular actor, that movie dialogue may be famous, so Indian knows like this is a movie dialogue, and if I'm searching that dialogue itself in the Google, so it will return the those pages where that actor has said something or something like that. But suppose if Chinese or a person in the US who is searching for the same dialogue, so he doesn't know like it is a dialogue, it is a movie dialogue, and he's searching for something, so he will not be returned the pages of that actor. So these, so basically context behind what a person is saying, a location, and so many other things are there. So that is why Bert is able to learn the context, in which context I'm talking. If I'm saying something, this means I have a background knowledge, like I watch Hindi movies and I'm searching for this dialogue. Okay, so Bert is very intelligent, you can say, in such a way like it is able to identify the context of a person in which a person is talking, whatever a language a person is using. Now, suppose I am giving a sentence as input to the search query in the Google. I'm searching for a sentence. Now, so Bert is background, it is running in the background, and right now it is in, I think, 5 to 6 languages. It is already implemented. For example, English, Hindi, and so many other languages. Uh, it's working. So it's very latest algorithm, but it is very much, it has gained very popularity in recent years itself. Now, let's see. So what is BERT? So BERT utilizes concept of transformers and bidirectional concept and multi-mask language modeling. So multi-mask is just like fill in the blanks. You have certain words that are masked. Mask means so okay. So model wants to predict those words, whatever those words were. So multi-mask is multiple missing words are there which are masked. Even if you are having such words, so you want to predict it so that model will train it better. Okay, so this is the concept of bidirectional. Bert, sorry, we'll check how this works later on. So these, so up till now, whatever I have told, so all these things will be used in Bert. So first of all, transformer will be used, bidirectional thing will be used, transfer learning will be used, and these three things will be used. And encoders. So encoders is nothing. We are just getting representations of the whole sentence. So four things are there while we are talking about Bert. So up till now we have discussed this sequence of few models that came in history, and where did Bert lie in those whatever we have models we have till now. So we have, although here we have discussed four five models itself in brief. There are so many other algorithms that are also very popular, so we are not getting into much detail of that. So T5 also came later on. So it utilizes the decoder as well as encoder. In this T5, so it is also very intelligent algorithm. What it does is it is able to do multiple tasks at once. For example, it can classify, it can summarize, and it can do question answering at once. So what you need to do is you need to give suppose you have trained your model, and T5, what T5 will do is, so you will give a label like classify. So I want to classify this sentence from whatever you have trained, so it will say okay, this belong to this class. Now suppose you want to ask a question, so in the same model itself you will ask a question and you will give label that it is a question, so that model will give you the answer of that question. So T5 is also very intelligent algorithm, and it is able to do multiple tasks from the same model itself. It can carry out multiple tasks. Now let's have a look at BERT. So we are just going to talk about BERT today itself. Um, okay, so there are four things. First is it is bidirectional. Second is encoder representations, and then third is transformers. So transformers, so for transformers we can say like it is just encoder decoder architecture. uh, then we have encoder decoder architecture, plus we have some attentions associated to it. We will say okay, we want to give we want to give more attention to few words, okay, that kind of thing. Then we have encoder representation. So whatever sentence we are having, we will generate a representation of it to learn what that sentence means. So suppose I'm giving a movie dialogue as input. So I want, and there is intermediate word also. So I want, for this word I want left context also, right context also, bidirectional thing. I want the meaning of the whole word. I want encoder representations. I want to give specific attention to particular word. So that is also there. And I want to, give, I want to generate and translate this sentence into maybe some other language. So this was suppose English and I want to translate it into Hindi. So that is encoder decoder. So again, so many things are associated in this Bert itself. Now let's move on to, so I think I have discussed this one. So in RNN there was no parallel computing. So then came transformer, and in transformer what we do is we just, whatever words we have given, so it allows us to do parallel processing. We can parallelly process. So it, this all will happen at time t is equals to 1. Like this was happening at t equal to 1, this was happening at t equal to 2, this was happening at t equal to 3. Then it is giving the output, and then it is generating something. So this is English language, this is some other language. Okay, so this was disadvantage in RNN. Now transformer is able to remove this one. So at once you are giving whole sentence as input, and parallelly it will process and generate your output, and it will give attention to those words. It will one attention layer is there, and it will give attention to specific words, and it will produce output. So parallel processing it allows. Okay, so but now next is positional encoding. So positional encoding is nothing, it's just suppose in the same sentence itself. So because in any language position of a word is very very important. So before, so if I'm talking about this word itself, so I cannot write like if this is cats eat rat, I cannot write that rat eats cat. Okay, so these two positions are different. So whenever I'm generating word embedding for each and every word, what I will do is I will add a plus one vector. I will add, in addition to my word embedding vector, I will add a positional embedding vector, and that will store the location. That will tell me the location of that word, position of that word with respect to next word and previous words. Okay, so position is important. So position encoding is nothing. In addition to embeddings, I will also store the position encoding of each and every word. Okay, now let's have a look at, so this is already built in Bert architecture having certain parameters, and it is pre-trained. Now let's have a look at final Bert model. How does it work? So these are the problems that can be solved with Bert. It can translate from one language to another. It can solve your question answering problem. It can generate sentiments, tell the sentiment of your text. It can summarize your text. So it can Bert can be applied to many problems. And there are two things whenever I'm training a Bert model. So first step is this one, and second step is this one. So in first step, so basically why we are studying Bert is we want to know what a person is. We just don't want to understand the words, we want to understand its word, we want to understand context, we want to learn the correct positions, like whether context is whether the sentence is written in the right way or not, text is written with the right position or not, all the words are grammatically correct or not. So many things we want to learn about a sentence, right? So that is why Bert is very very important, because it is able to identify and solve all those problems once at once. Okay, so how it does is, so first of all, it, there are two things it does. First is it pre-trains to understand the language, what the person is saying, what the person wants to say. And second, it will fine tune it and utilize the transfer learning to whatever it has already trained upon. Okay, so first of all, it will train itself to understand the meaning, the context, the whole language, the whole sentence that is given as input. And second thing is it will fine tune Bert to learn specific tasks. Okay, it will fine tune means it will fine tune the model that it has already trained upon, and it will not start learning from the scratch. Whatever it knows, it will utilize that information for a particular task, and that task can be your question answering, sentiment analysis, anything for any application. So that is the whole idea behind a Bert. Okay, clear? I mean, what Bert is doing. So we will see like why how this Bert is able to do this. Now let's see. So first thing, whenever I'm talking about Bert is, so it does two things at once. So first of all, so pre-training involves knowing the language or knowing the sentence that you have given. What is the context of the language? Whether that sentence was a movie dialogue, or whether that sentence was the person is actually searching that sentence in the Google. Okay, so first is it will create mask out certain words, and it will generate some um, it will generate a model for this, for masked out words, and it will predict the masked words. So the dash brown fox, the dash over the lazy dog, it will predict the dash words, and it will train your model on that. Now the second thing it does is, in pre-training itself, there are two parts. So first is it will mask language modeling, and second is next sentence prediction. So whatever the first sentence was, it will predict next sentence. So this was your first sentence. Suppose it will predict your next sentence. So it will do these two things, and uh, it will do pre-training. So in pre-training, from your data set itself, it will run two models. First is mask language model. It will mask out certain words and predict those words to better train the model, and then it will do next sentence prediction. It will give input previous sentence, and it will output the next sentence. So these two things it will do for pre-training. Okay, after the model has trained, it will be having certain weights. Now those weights, what it will do is it will fine tune those weights. So it is now having certain weights. Weight metrics are already there. Now suppose now after this you have generated pre-trained weights. Suppose you want to find out question answer. You want to give some question as input, and you want answer. So what you will do is you will just add certain number of layers. So this model was already learned from so instead of learning from scratch, you will just use those weights, and you will add few layers to it, and you say, okay, this was my question, and I want answer for this. So you will get answer for this one. So it is just increasing, instead of doing everything from the scratch, you are just using whatever knowledge you were having previously, and it will use that knowledge to solve whatever application you want. Sentiments of your data, you want question answers for your data, so everything can be performed in the second step. So this is the idea behind Bert, and this process goes on. So it will go back again to that one. Again pre-training will done, and these two, in pre-training again these two will happen, and then it will again fine tune those models according to the text that you want. So this is about Bert. So overall idea behind Bert. Okay, so that is it for today. Any questions about this, anything? Or if you want to get into details of this, we can get into details about like how it is happening and how these weights are getting generated. Okay, do let me know.